In the vastness of the ocean, where attention is often drawn to giants and predators, there exists another realm entirely, one defined not by size or spectacle, but by compression, pressure, and invisibility. Between individual grains of sand on the seafloor lies a universe so small that entire ecosystems unfold beyond the reach of the naked eye. Within this hidden world lives the Kinorhynch, an animal so minute and obscure that its existence challenges the very boundaries of what humans consider noticeable life. Kinorhynches are microscopic marine invertebrates, typically less than 1 millimeter in length, yet they possess a level of anatomical complexity that rivals animals thousands of times larger. Their bodies are divided into distinct segments, each encased in a rigid, cuticle-like armor. At the front lies a retractable head armed with rings of spines, structures that give rise to their informal nickname, mud dragons. This head can be extended and withdrawn like a mechanical probe, allowing the animal to anchor itself, move forward, and interact with its environment in ways uniquely suited to life at microscopic scales. The evolutionary origins of Kinorhynches trace back hundreds of millions of years, placing them among the ancient lineages of marine life. Fossil evidence is scarce, not because they are young, but because their size and soft tissues leave little trace in the geological record. Instead, their history is reconstructed through comparative anatomy and molecular data, revealing relationships to other ecdysozoans, animals that grow by shedding an external cuticle. This places Kinorhynches in a broader evolutionary context alongside arthropods and nematodes, despite their radically different lifestyles. Life between sand grains is defined by constraint. Space is limited. Movement is resisted by friction. Water does not flow freely but clings to surfaces, forming thin films that behave differently from open liquid environments. In this setting, speed is irrelevant. Survival depends on precision, anchorage, and the ability to exploit microhabitats invisible to larger organisms. The Kinorhynch's segmented body and spiny head are perfectly adapted to this reality. Movement for a Kinorhynch is a slow, deliberate process. The head extends, spines grip surrounding sediment, and the body contracts forward segment by segment. This inching motion is repeated endlessly, allowing the animal to navigate the labyrinthine spaces of marine sediments. There is no wasted energy, no unnecessary motion. Every action is functional, refined by evolution to operate under constant resistance. The armor that encases a Kinorhynch is not merely protective. It provides structural integrity in an environment where pressure fluctuates with every shifting grain. This cuticle must be strong enough to resist compression, yet flexible enough to allow movement. Periodically, the Kinorhynch undergoes molting, shedding its old cuticle and forming a new one. During this time, it is especially vulnerable, a reminder that even the smallest armored creatures face moments of exposure. Feeding occurs at an equally small scale. Kinorhynches consume organic particles, bacteria, and microalgae embedded within sediment. Their mouthparts are adapted not for biting or tearing, but for scraping and ingesting material from surfaces. In doing so, they participate in the recycling of nutrients, breaking down organic matter and contributing to the health of benthic ecosystems. Though individually insignificant in size, their collective impact is substantial. The habitat of Kinorhynches spans marine environments worldwide, from shallow coastal sands to deep-sea sediments. They tolerate a wide range of conditions, including low oxygen levels and high pressure. This tolerance suggests a resilience built not on adaptability to change, but on specialization for stability. Kinorhynches thrive where conditions remain relatively constant, where the sediment structure persists long enough for slow life processes to unfold. Predation in this microscopic world is subtle. Larger microfaunal organisms, such as nematodes and small crustaceans, may prey upon Kinorhynches, but encounters are rare and often incidental. The true dangers are environmental, sediment disturbance, changes in chemistry, or shifts in microbial communities. When the seafloor is disrupted by storms, currents, or human activity, the delicate architecture of interstitial spaces can collapse, eliminating habitats in an instant. Despite their obscurity, Kinorhynches play a crucial role in marine sediments. They are part of the microfauna, a group of organisms that form the foundation of benthic food webs. By processing organic matter and interacting with microbial populations, they influence nutrient cycling and sediment stability. Their presence is an indicator of ecosystem health, reflecting conditions that support complex, stable microhabitats. Studying Kinorhynches requires patience and specialized techniques. They are extracted from sediment samples through careful washing and filtration, then examined under powerful microscopes. Even then, identifying species demands expert knowledge, as morphological differences can be subtle and highly specific. Each discovery adds to a growing understanding of biodiversity that exists beyond human perception. In the context of life on Earth, Kinorhynches represent an alternative strategy for survival. They demonstrate that complexity does not require size, that armor does not require bulk, and that dominance can exist entirely unnoticed. Their world is one of narrow spaces and slow movement, yet it is no less dynamic or important than the realms occupied by larger animals. Between grains of sand, where pressure and friction define existence, the Kinorhynch continues its quiet journey. It does not conquer territory or display strength. It persists, and in doing so, it reminds us that much of life's history, and much of its future, unfolds far below the threshold of human sight. In a world measured in fractions of millimeters, reproduction is not a dramatic event but a calculated continuation of existence. For Kinorhynchs, survival across generations depends on precision rather than abundance. There are no vast swarms, no explosive population booms. Instead, there is balance, maintained quietly within the tight confines of sediment and time. Reproductive strategies among Kinorhynchs vary between species, but they share a common theme: efficiency under constraint. Most Kinorhynchs reproduce sexually, with separate males and females, though external differences between the sexes are subtle and often invisible without magnification. Mating occurs within the sediment itself, in spaces so confined that traditional courtship behaviors are impossible. Contact is brief, functional, and dictated by proximity rather than choice. Fertilization leads to the production of eggs that are relatively large compared to the size of the adult. This investment reflects the risks of the environment. Each egg contains enough resources to support early development without reliance on external feeding, a crucial adaptation in habitats where food availability can be unpredictable at microscopic scales. Eggs are deposited directly into the sediment, where they remain protected from currents and many potential predators. Development proceeds without a free-swimming larval stage, a notable contrast to many marine invertebrates. Instead of drifting into the water column, Kinorhynch offspring develop directly into miniature versions of the adult form. This strategy minimizes exposure to open water dangers and ensures that juveniles begin life already embedded within a suitable habitat. From the moment they emerge, they are part of the interstitial world, navigating the same narrow passages as their parents. Growth in Kinorhynchs occurs through a series of molts, each one marking a step toward maturity. With every molt, the animal sheds its old cuticle and expands slightly, adding complexity and strength to its segmented armor. These molts are moments of vulnerability, as the new cuticle takes time to harden. During this period, Kinorhynchs often remain inactive, relying on concealment rather than movement to avoid danger. The number of molts and the duration of each developmental stage are closely tied to environmental conditions. Temperature, oxygen levels, and food availability all influence growth rates. In colder or more stable environments, development may be slow, extending the lifespan of individuals but reducing reproductive turnover. This slow pace reflects a broader pattern among microfaunal organisms, where stability favors longevity over rapid reproduction. Within the sediment, Kinorhynchs coexist with a dense and diverse community of microorganisms and other small invertebrates. This microscopic ecosystem is structured vertically, with different species occupying specific layers based on oxygen concentration, grain size, and organic content. Kinorhynchs typically inhabit zones where oxygen is present but limited, a niche that excludes many larger or less specialized organisms. Interactions within this ecosystem are subtle yet constant. Kinorhynchs compete indirectly with nematodes and copepods for microbial food sources. They influence bacterial populations through grazing, shaping the microbial landscape in ways that affect nutrient cycling. In turn, they are influenced by the chemical byproducts of microbial activity, which can alter sediment conditions over time. Environmental stability is critical to this balance. When sediment structure is disturbed, whether by natural events or human activity, the intricate network of interstitial spaces can collapse. For organisms like Kinorhynchs, such disruption is not a temporary inconvenience but a potential extinction event. Recovery depends on the gradual re-establishment of suitable conditions, a process that can take far longer than the disturbance itself. Human impacts on Kinorhynch habitats are often indirect and largely unnoticed. Coastal development, pollution, bottom trawling, and climate-driven changes in sediment composition all alter the physical and chemical properties of marine sediments. While these changes may seem minor on a human scale, they can profoundly affect organisms whose entire world exists within a few centimeters of sand. Because Kinorhynchs are sensitive to environmental conditions, they have become valuable indicators in scientific research. Their presence, absence, or community composition can reveal information about sediment health, pollution levels, and long-term ecological stability. In this way, organisms that are rarely seen contribute quietly to our understanding of marine ecosystems. Scientific interest in Kinorhynchs has grown steadily as technology advances. Improved microscopy, genetic analysis, and sampling techniques have revealed a diversity far greater than previously imagined. New species continue to be described, each one offering insights into evolutionary processes that operate at microscopic scales. These discoveries challenge assumptions about how complexity arises and is maintained in extreme environments. From an evolutionary perspective, Kinorhynchs occupy a unique position. Their body plan represents a successful solution to life under constant compression and resistance. Segmentation provides flexibility, armor provides protection, a retractable head allows interaction with the environment without exposing the entire body. Together, these features form a system optimized not for expansion or dominance, but for persistence. In studying Kinorhynchs, scientists are reminded that much of Earth's biodiversity exists beyond the limits of casual observation. Entire lineages thrive without ever being noticed, shaping ecosystems in ways that remain largely unrecognized. These organisms do not rely on visibility or abundance to succeed. They rely on fit. As conditions in the oceans continue to change, the future of Kinorhynchs will depend on the preservation of sediment stability and chemical balance. Their narrow tolerance ranges make them vulnerable to rapid shifts, yet their long history suggests a capacity to endure gradual change. Whether this endurance will be sufficient in the face of accelerating human impact remains an open question. Between the grains of sand, life continues at a pace that defies human urgency. Kinorhynchs move slowly, grow slowly, and reproduce deliberately. Their existence is a testament to the idea that survival is not always about progress or expansion, but about maintaining equilibrium in a world that rarely notices you are there.